Great. Well, I'm certainly very happy to be here. My name is Mark Billinghurst from the University of Canterbury in Christchurch, New Zealand, and so I've travelled a long way to be here. We've already heard a little bit about augmented reality, and that's what I'm talking about today. But like many of you, you probably can remember back into your childhood where you had a movie or some theatre experience that really influenced you, and the one that influenced me was Star Wars. So when I was very young, I saw the Star Wars movies, and this was from the third Star Wars movie, I guess it's the sixth movie now, and this is when they're all just sitting around the table trying to decide how they're going to destroy the new Death Star. So you can see, unlike PowerPoint today, and in the Star Wars era, the model of the Death Star appears as a 3D virtual image, and they can all see each other in the real world as well as the Death Star floating in front of them. So this has influenced me very much when I was very young, and I decided I want to try and make this vision that George Lucas had real. And of course, this is a classic example of what we call today now augmented reality. So augmented reality really has these three defining characteristics. It combines real and virtual images. The images are interactive in real time, and they're registered in 3D, so the Death Star model sits on the real table. So when I was young, as I said, I really wanted to make that, and when I started my PhD a long time later, I had the opportunity to do that. So fast forward now from 1983 to 1999, and I developed this experience at the SIGGRAPH 1999, which is the big computer graphics conference. So in this time, you could stand across the table from each other. You could look on these black and white cards that we developed a tracking library for, and you would see virtual objects appearing off the cards. Let me show you a video of this running. So this is an old video, so it's quite small, but here you see my friend Lily turning over a card, and you can see a little green alien appearing stuck on the card. And so this is kind of classic augmented reality where you can see virtual objects appearing in the real world. And she's playing a game with her friend, so when she looks across the table, you can see her friend Richard there, and he can also manipulate the card as well. The key thing, though, just like in the Star Wars movie, they can see each other both in the real world at the same time as they can see the virtual images. So if I wanted to, I could have taken the little green alien and I could have replaced it with the Death Star, and we could have reproduced the scene from Star Wars. So that's kind of classic augmented reality from a long time ago. And by doing that, I learned that there are several important things in designing augmented reality systems. The most important thing is that unlike designing other computer components or systems, is that augmented reality has a strong connection back to the physical world. So traditional HDR is often concerned about what happens just on the screen, although at the workshops this week you'll learn a lot more about off-screen things as well. But augmented reality really is concerned about what happens in the physical world because the digital content is anchored in the physical world. And then most importantly, how do you interact between the physical world and the virtual content, and how do your interactions map using some interaction metaphor to manipulate that content. So about the same time as I was doing that, Steve Feiner and others at the University of Columbia were developing mobile augmented reality systems. So you can see a person on the right there who's wearing a backpack computer walking around the real world. And so again, you have to think about designing this system like this. You've got to think about what are the physical elements, what are the virtual elements you want to show, what's the metaphor you can walk around. And in this case, the metaphor that they used was really information in place. So you can walk around the real world, you look at real buildings, and you can see tags appearing on top of those real buildings. Of course, you have to have a huge backpack at those times. So when I developed my first AR system in 1998, this was the Silicon Graphics computer it ran on. Some of you may have used a computer like this, especially the older ones in the audience, but it's got a 300 megahertz CPU, 9 gigabyte hard drive, a RAM of half a gigabyte. Most importantly, it had a camera that plugged directly into the computer, and it let you record video at video quality video at high frame rate, and it also had a dedicated graphics card that produced fantastic graphics. So around 2006 or so, the phone I was using at the time was a Nokia N95, 2008, and if you look across, you see very similar statistics. So of course that meant that in the 7 or so years since I developed the SIGGRAPH shared AR experience, we could then take that experience and we could bring it to mobile phones. And with mobile phones, of course, you have a camera, a processor, and a display, so everything you had in that O2 computer can now be in the palm of your hand. And so that's what we did. In 2005, we made it the world's first collaborative mobile AR experience running on mobile phones, which was a simple tennis game. So let me show you this video of this running. There we go. So again, when you watch this video, you should think about what are the physical components, what's the digital content I'm showing, what's the metaphor that's been done here. So in this case, you have two people sitting across the table. They each have old Nokia phones. I think this is a 6630 phone. And they look at this physical piece of paper, and this paper does the tracking in the real world. And then the metaphor is that you're supposed to imagine that your phone becomes a tennis racket. And as you move your phone relative to the paper, you can hit a ball off the paper and play tennis with each other. And so you can see here, here's the virtual tennis court, and I can move around and I can bounce the ball around. We had a physics model, and there was Bluetooth, so that the system was entirely self-contained. You could send data to each person using Bluetooth. Of course, that's a long time ago now, and we can do the same thing now without necessarily having to have that printed marker, and the frame rate would be not 7 frames a second, but 30 or 40 frames a second. So in the 2005-2006, the first computer vision-based AR systems began to be developed, and they had very many use applications. So this is another application we developed, which was the first mobile AR advertising campaign. So you could open up a newspaper, you would see, and this is for the Wellington Zoo, you'd see zoo animals come to life out of the newspaper. Of course, in 2008, you started seeing the first location-aware phones on the market. So the Nokia Navigator from Finland, a variety of Android devices. So that went now is that now you could take your AR experience as outdoors, and you don't have to look at pieces of paper anymore to see the visual content, but now you could use the GPS and compass in the device to move around the real world. And this allowed you to do a real-world information overlay. And so a large number of companies have developed now that build these types of applications. One of the most famous is Leia, and Leia lets you walk around the real world and see virtual tags appearing in the real world, showing you where different, in this case, cafes are. I think Leia has about 30 or 40 million downloads right now, and it's one of the most popular mobile AR applications in the market. The way these applications typically work is they're a client-server-based system, so you have an AR browser client on your phone, and then you send requests back to web services, and you can get access to large amounts of content. So, of course, this means that anybody who can write a website can now deliver content to your mobile AR device. At the HitLab, we developed our own mobile AR platform, and it's pretty much the same as Leia. In our case, we're focusing on museum guides initially and buildings. And so you can walk around the real world, you could have a 3D model visualization, you could position content in space using your camera, GPS, and your compasses. However, the year after we built this, something very tragic happened in New Zealand. There was a huge earthquake in my hometown of Christchurch. So this was in 2010. And what you may not realize is that when you have earthquakes like this, there are often many aftershocks. And so from 2010 until 2012, we had 11,000 earthquakes in my hometown. And what that meant was that about 70% of the downtown of our town has been demolished or will be pulled down in order to build stronger buildings. So many of the buildings that we knew and loved have gone. So when we saw this, we took our mobile AR platform and we used it to put back in place the buildings that used to be there, and also as a planning tool to see what could be there in the future. This is a map of the demolition. So each of those little points of interest on Google Maps represents a building that's been demolished, or if they're green, will be made safe, or red, partially demolished. So you can see most of the downtown area is gone. So we developed an application called City View AR. This is the city library, the oldest city library. It was the oldest city library in New Zealand, and it's halfway to be demolished because it couldn't be strengthened to withstand further earthquakes. So we developed this application called City View AR that used outdoor augmented reality to visualize Christchurch city buildings. So you can walk around the real world and see buildings put back in place. It's available now on the Android, and also just last week came on the iPhone market. So what I wanted to do is give you a small live demonstration of this. See, hopefully it'll work. So there's my my iPad, and now we can go to the City View AR application. Now, of course, we're not in Christchurch right now, So if I start this up, you can see a Google Maps view of the city, and then it's going to ask me if I want to fake my location, so I say yes, and it's going to move me down to here. This is Cashel Mall. This was the oldest shopping street in Christchurch, and all those buildings that have tags on them, they've all gone now. So, for example, this is the Zetland Hotel, which was one of the oldest hotels in Christchurch. You can see a little bit of view of the hotel there. Here's some pictures of what it used to look like and so forth. So what I want to show, we have a map view, then I want to show you an AR view. So if you swap to the browser view now, what happens is that if I look around, you will see, around this way I guess, you'll see over there some buildings appearing. Now it looks a bit silly in the auditorium, but if I was standing at the edge of Cashel Mall, all the buildings that have gone in Christchurch have mostly become parking lots, and so all these parking lots will be replaced by buildings. So you can see what the city used to look like. If we go back to the map view, you can also see panoramas that were taken a week after the earthquake, and so we have this immersive 360 photo bubble. So if I look this way, you can see the cracks in the building up there. If I go this way, you can see the frontage of these buildings have come off as well. I remember when I was in Finland working at Nokia a long time ago, they had a magnitude 2.4 earthquake in the north of Finland, and it made the front page news. In Christchurch, we don't get out of bed unless it's a 3.5 earthquake. And the one that devastated the city was a 6.1. Well, it was 7.1 the year before, and the 6.9, sorry, that did this damage. So that's one use of using augmented reality to take and reconstruct what the city used to look like. A second use is for future planning. So let me give you a little example of this. So we're having a new city built now, and this is what it kind of looks like. You can't hardly see that, but basically all this green area here is city blocks that are being mostly demolished and made into a park. So people in the city are interested in what it's going to look like. So what we did for the city is we took this map here and we made it so that you could see, put back on top of the map what the city would look like. So let me go back to here, and I can click on this one. And now what we're going to do is use visual tracking to track off the map and overlay content onto the map itself. It just takes a second to start. And this is using the Vuforia tracking library and also the Unity game engine to do the, there we go. And now it has to find the map, and it's having a hard time finding the map. Let's see if there we go, give me some more space. There we go, so you can see on the map here, all these little tags appearing, showing the different precincts going to be put onto the map. And if I wanted to, I could tap on one, like the convention centre, for example, and now it has a 3D model of the convention centre appearing. And you can highlight different parts of the model and go back, or you can look, for example, at the stadium. And you may not be able to hear that, but you can hear the volume of the crowds, and as I go in and out, the crowd gets softer and quieter. So this is an example of how you can use augmented reality to inform city design. Let me just go back to my slides here, just a couple more slides to show you, and then I'll be done. I only have a couple more things to say. So one of the things I wanted to say was about design, and that is the current AR experiences all rely on mobile phones. So if I take my, or tablets, so if I take my iPad outdoors and start walking around like this to look at the city, or if I take my phone around like this to look at the city, it's quite an unnatural way of interacting with the real world. In fact, there's a Swedish company called TAT that makes some very interesting concept designs for in terms of augmented reality. And one of them was to be able to take your phone and to point at people, and when you can recognize their faces, it will pull up their Facebook pages, LinkedIn sites, and so forth. And it was a very, very useful application, especially somebody like myself who forgets people's faces very quickly. So you can imagine you're sitting in a meeting, it's a very serious business meeting, maybe Olbric's giving a presentation, and I pull my phone out and start pointing it around the room. You can imagine what that makes you feel like. One of the user subjects that they tested on said that it would make them feel like they're being scanned by the police, and he said if somebody did that to me, I want to punch them in the face. So obviously the experience we have with AR right now is not ideal. So in the workshop, we're going to talk about how we can design new types of experiences that will enable us to engage with the city in new ways, but also look at using new devices. And so currently the form factor for AR devices have gone from a backpack wearable system to a handheld wearable system, but there are still some social and contextual issues with that. So I've also brought with me, I'm very fortunate to have a pair of Google Glasses. So here's my Google Glass display. And so now this has taken essentially everything that's on the phone here and put it into this device here. So I have, for example, a camera, microphone, the CPU is all inside here, the battery is all inside here, and so now I can start engaging with the world through an augmented reality device that I wear on my head, and which, of course, there are still some social consequences, but it's a lot less socially restrictive than pulling a phone out in the middle of a meeting and pointing at people. So the people in my workshop will be learning how to use AR browsing software to create experiences that will let them engage with the city in new ways. And some of them, if they want to, can also learn how to develop for the Google Glass and look at how you can develop new types of social and AR experiences in that way as well. I just want to show, to close by giving you a conclusion slide, if I can just wait for a second while my machine reboots up. I should also talk about, in our course we're going to talk also about how to look at new metaphors that are enabled through the use of AR experiences. So I've talked so far about how when you're designing for AR experiences you have to think about the physical and the virtual world and the metaphors connecting the two of them. But one of the most important elements of AR design is thinking about the user itself. And in fact, there are 5 aspects of the user you need to think about. You need to think about the physical ability of the user to use your interface, the intellectual ability of the user interface, but you've also got to think about the social and emotional elements of the user interface as well. So when you are engaging with an AR experience and using a phone in a social context, that's very different than when you're wearing a pair of glasses and looking at people through those glasses. Okay, so just to wrap up, what I want to mention is that, first of all, mobile AR is a rapidly growing business. The projections are that by 2017 there'll be a $5 billion business. By 2020, 1 billion people on the earth will use mobile devices of one type or other. But there's a need for better designed experiences. As I said before, with the TAT experience, you have a good what might be a good idea, but when you actually think about using it in context, it really doesn't work out. Somebody said it'd be like being scanned by a security guard, or they're going to deserve a punch in the face or a lawsuit. Things like Google Glass will avoid that and provide new types of AR experiences. But you need to design those experiences by considering the user needs, thinking about user interaction design principles, and designing the various elements as well. Here's my contact metaphors, and I want to leave you with just one little advertisement. I'm also the chair of a symposium on mobile graphics and interactive applications at SIGGRAPH Asia. And so for those of you working in the mobile space, you should think about submitting a paper to this conference. It's in Hong Kong this year, and the deadline is June 17th, so that's just really close. But fortunate for you, you only have to write a 1-page abstract. So for those of you who are in my course, I'll be more than happy to help you write those abstracts, and you can submit them in, and hopefully you'll get to see each other again in November this year. SIGGRAPH Asia is the largest computer graphics conference in Asia, so it's a great place to go. So that's all the slides I had to show. Sorry for the technical problems, and I'm not sure if there's time for questions, but I'm happy to take a few questions as well.
All right, thank you, Mark. Time for a couple of quick questions. Anyone has one?
I was wondering about sort of the social issue. You said sort of, yeah, if somebody holds the phone in your face,
right,
you get this response, I would rather punch that person.
Some people
and I think with Google Glass, we had a lot of discussions, sort of how much more acceptable it is if it's not really seen. And I think people at Google, some of them have argued they do speech interaction in order to make it very explicit, in order that you don't do exactly what you argue, that you sort of can do it hidden. Right. So what is your take on it? Do you think it's sort of, we will just change our values, as sort of I hinted earlier, that we will not care in a few years, or is it something which is fundamentally different between the phone and the glass?
Well, there are some differences. So, of course, Google Glass makes it much easier to capture content, but with the current design, Google have also made it very obvious when you're capturing content. So one person wrote an article a week ago saying it's the worst surveillance device in the world. They started their article by saying, imagine I had a device I could wear that cost $200 and I could walk into a meeting and record the whole meeting that was happening. Would that worry you? And of course the implication was it was, but those devices are already available. You can already buy pens with microphones and cameras in them, or glasses with hidden cameras in them. But with Google Glass, you have to, if you're recording, you have to push a button or use a speech command to record. Of course, you have to wear the device on your head, so as soon as you walk into a room, everybody knows you've got Google Glass on the head. If I reach up and the button, then everybody knows I've taken a photograph, or if I say Google Glass, take a picture, of course, everybody in the room knows. Then when you're recording, you have a light that goes on, the display turns on itself. So I think one of the challenges is that not many people yet have had experience with the technology, and if you, I guess, as has been alluded to already in the presentations, if you haven't had experience with the technology, you can be afraid of it. I remember the first time I was I was flying through an airport, and I saw a man standing in the corner talking very loudly and waving his arms around, and I thought he was kind of a crazy man, until I saw that he had in his head a little thing, and I realized it was a Bluetooth headset. And it was the first time I'd seen somebody talking with a Bluetooth headset. So I think it'll be the same with Google Glass. Once people become more aware of it, we'll develop social norms to adapt to its use. For example, I spend part of my time at Google now on sabbatical, and in Google, when people go to the bathroom, there are many people wearing Google Glass at Google. They always either take their glasses off or put them on the top of their head or on the back of the neck, so other people in the bathroom know that there's no chance this person's going to record me by mistake. So I think it'll be a case of social norms and a transition to develop new technology. And it may be very much like you're saying, Elbrick, that in 20 years' time, everything about my life that's in a public setting could be recorded and captured, so we don't care anymore, because there's such a volume of data that if anybody wants to follow me or find out about my boring life, they can do it easily.